All right. Welcome, Scott. Great to have you
Thank
in
you.
the discussion today. So, Scott, you spent 34 years in the data science industry. So, you bring in great wealth of experience and knowledge to all the people who watch our YouTube channel.
Thank you.
And I really appreciate that you accepted our invite in the first go itself. Thanks a lot. How are you doing?
Absolutely.
How are you doing?
I am doing well. How are you doing?
Good, good, great. Thanks a lot.
Excellent.
So, well, I see that you are a lead data scientist with Franklin Templeton, one of the
Yes.
largest mutual fund houses in the world as well as in India. So, how's it going for you? What are the things that you do for them?
It's going great. We just did a big transition. I was working for a different company called Legg Mason, and Franklin Templeton acquired us.
Okay.
So as of August, I have been a Franklin Templeton employee. As lead data scientist, I do a lot with advocacy within the organization, sort of the internal evangelist, working on developing training programs and assisting other areas of the business build predictive models.
Oh, okay, great, great, great. And I saw in your profile that one of the things that you say that you like to improve ROI. So that was one of
Yes.
the important things. So would you call yourself an ROI improver, or would you call yourself as a business problem solver?
I think I would go with business problem solver, but the problems should all be related to ROI.
Okay.
I'm going to launch a campaign to make ROI stand for return on information instead of return on investment, because there's such a big push. There are so many folks who get all excited about new algorithms like LSTM and adversarial neural networks, and that's all well and good, but it doesn't help a whole lot if you're not solving a problem for your organization that's really going to matter to them.
Very, very good point here. So we see a lot of data science aspirants who we come in touch with. The focus remains on the hype words like learning, deep learning models, neural networks, and so on and so forth. So what kind of advice would you give to them, somebody who's just starting their journey in the world of data science?
I think one of the things to be aware of is that I believe that the hiring system for data science in general is kind of broken. And let me explain what I mean by that. There is a huge focus in human resources departments to focus on coding.
Okay.
And that's all well and good, and it's really important. And it's not that I pass aspersions on that. It's great to be able to code.
Okay.
But if you're coding the wrong thing, it doesn't make any difference whatsoever. So one of the big things that I would suggest to folks is that there's a dirty little secret in data science, and that is that it's about people.
Okay.
And what I mean by that is whether you're doing it for internal clients or external clients or whoever else, you need to be able to meet the needs of that person.
Mm-hmm.
And data science is a tool to be able to do that. Data science is not an end in and of itself.
Okay.
So my advice to folks is to realize that as you pursue getting into the field, learn to ask a couple questions. One of the questions is, all right, pretend you had the model today and I'd already finished the model for it. What would happen then? And the reason why I suggest that is Gartner indicates that 85% of all predictive models never reach production.
Okay.
That's horrifying. So I don't know of too many fields of endeavor where you can keep a job for very long with a 15% success rate.
Yeah.
So make sure you understand how the model is going to be put into place, or how the analysis is going to be put into place, and find out what are the real issues behind it. What are the questions that people want answered? Work on that first. The push is usually, it's really exciting. I've got a new data set, woohoo! And I want to go in and I want to do EDA and I want to do visualization. And I want to do this and I want to do that. I want to try this brand new algorithm I just read of on Tour Data Science. That's all well and good. There's a time and a place for everything. Make sure you understand the problem and how to solve it, then take care of the other things.
Very good. So your message, main key message is that focus on the business questions to begin with.
Yes.
And don't get excited with the techniques of it. And you gave an example that coding is good, well and good, but ultimately, as you said, 85% of the models do not go into production. So
Right.
they don't go to production because probably they're not answering the right questions, right business questions.
I think that's a big part of it. And also, I think people are really attracted to algorithms. For lack of a better phrase, I would say algorithms is the sexy part of data science. But unfortunately, a lot of success is sort of the basic blocking and tackling. It's the basic steps of making sure that you define the right dependent variable, that you know what the business outcome needs to be. You know how soon it needs to be delivered. You need to understand all of those types of things, which a lot of folks find boring. Unfortunately, so many folks are interested in going after the sexy stuff that you end up with a lot of failure. And I'm really concerned that there's going to be a big blowback for our industry, because so many people are interested in the fun stuff and the interesting, what they consider interesting, but they're failing on actually getting the problem solved.
Okay, so as per you, a data scientist's main definition is that they should solve a business problem.
Yes.
Is that what you're trying to say across?
Absolutely.
Okay. And how do you suggest somebody build that skill?
I think it has a willingness to ask a lot of questions. And when I mean ask a lot of questions, I don't mean bury the person in questions, but there's a certain order to things, and people tend to skip understanding the business situation, the organizational situation. Who are the players involved? Who needs to sign off on this model? Have I met with them? Has my boss met with them? Have I asked them what they need to see to be able to approve this? Let's say you're building a fraud model and it needs to go into production. How fast does your model need to be? So, for example, in the world of fraud models, especially if it's online fraud, you typically have sub-second response time to be able to take the data in, do your feature engineering, come up with a score, and put it back on the person's screen behind their computer to figure out whether it's approved or not. You're not going to do that with a convolutional neural network. It takes too long. But people don't tend to ask those types of questions. So you need to understand what are the parameters, and you do that by having a series of questions. And it doesn't have to be 100 questions, but there's at least a handful that you should really understand. Also, there is a big urge to do what I refer to as the reveal. Long time ago, when I worked with marketing analytics, we would have advertising agencies present to us. And their favorite part was sort of bringing up the board with the ad and pulling back the curtain to say, isn't this a fantastic ad? Awesome. If it's for the wrong product, which happens, that's not very helpful. So, a lot of people want to do the big reveal. Don't do that. Work with your internal client all through the process to make sure you're getting to where you're supposed to be. It needs to be a collaborative endeavor, for lack of a better phrase. Yeah,
very good point, actually. There, very good point. I really like the fact that you spoke about the speed of the model matters quite a bit, and you gave a very good example of fraud detection, especially in online fraud detection, because sub-second decision making is required there, and that is where the speed of the model would be very, very important. And if you do not ask that question and you end up using one of the data intensive and processing intensive deep learning model, then you'll end up wasting a lot of time.
Absolutely. And you're going to end up with a very unhappy internal or external client. And that's what's the career killer.
Yeah, that's a very good point. So I understand that business problem solving is very important. How about being able to communicate what you were able to find, or articulate what you were able to find in the model outputs, as we call it, the model interpretation? How's that as a skill to have as a young data scientist?
It's important, and I'm going to recommend a resource that I don't think you'll hear from anybody else, and that's called The Hero's Journey.
Okay.
It was a book written back in the 70s about a study of myths across cultures and storytelling. And you may think, why on earth is this wackadoodle going off about a book about storytelling? Well, it turns out that it's really successful in terms of identifying your client, internal or external, is the hero of the story. So you want the hero's journey to be their story. All right, so you set up, what is the problem? Then who is the hero? Then what is the main challenge that they faced? How do they overcome it? What's the end of the story? If you think in those terms, it'll be really helpful. And one guy who seemed to really like this book back in the 70s is an obscure guy. You may have heard of him, George Lucas. Okay. Who came up with, this tiny little indie film called Star Wars.
Yes.
And if you go back, that is actually what he used as his guidebook on building the script. You're not trying to create Star Wars, but at least following the steps of the hero's journey and the storytelling is going to give you a structure to be able to put all that fantastic analysis in to explain it to whoever needs to use the model.
So basically putting structure to your analysis process. And you gave a very great analogy. You took an example of George Lucas script building process to building an analysis model or framework for data science. Amazing.
And I realized that on the surface of this sounds silly. And people are like, oh, gosh, I don't want to do that kind of weird stuff. I want to do my model. And I want to show how many hidden layers are in my deep learning neural network. Okay, no one cares. They really don't. They do not care. They want to understand what the problem was, what you did to fix the problem, and how you're going to be able to fix the problem. And if you can't find a way to communicate it, your model's not going anywhere.
Absolutely right. I think, I can relate to one of our experiences. We worked with one of the largest US-based manufacturer, Honeywell, and, we were helping 400 plus young data scientists who Honeywell had recruited. And one of the main messages that they said to train them upon was that just help them understand how to interpret the model outcomes. And they specifically said, they said, if we can do something with regression and classification models, we should first try and focus on them before you go into, machine learning models or more deeper deep learning models. So I think I can relate with that. And they said specifically that let's first define a methodology, like an analysis methodology, and a lot of focus on storytelling. So I can quickly very well.
And along those lines, decision trees are your friends.
Yeah.
And the reason why is if you have this condition, this is what you do next. People can follow that. Early in my career, I wanted to show off this fantastic advanced neural network model, and I'm like drawing stuff on the board and I'm doing all this stuff, and you could just see the audience like this, and they were completely tuned out. People fear what they don't understand.
Yep.
And people hate that which they fear.
Yeah.
Okay.
Right.
So if you follow that along, if they don't understand your model, they're going to hate your model. That is not where you want to be. And that's why the storytelling is so important. It is critical to be able to get across the goal line.
Very, very good point. I think a very, very good point. And we've also observed among the learners in our data science programs that people who can actually build stories around the business problems first, they actually end up doing significantly better in their career as well. There is a strong correlation between that versus somebody who comes with a computer science background and who are great coders. So we have also observed that bit as well. Scott, I wanted to ask you one interesting question, probably changing the subject a little bit. I've seen, you spent significant amount of experience in, years of experience in this industry. And probably you started when probably data science was not even called data science. So I just wanted to understand, probably for our viewers, that how did you get into it? How did you decide to get into it back then?
Well, one day I was riding my dinosaur into work with my stone chap. No, I'm not quite that old. Yes, I'm very old, not quite that old. The way I got into it was actually by accident. I had started off in analytics at Citicorp and was there for a number of years.
Okay.
And then I made a change to a different organization who was launching a data science department. This department wanted to do data science on marketing. Okay, great. So in a marketing department back in the dark ages, we used to do a lot of direct mail. And a typical response rate to a direct mail program might have been 1.1%. Well, that means you're failing, 98.9% of the time. So if we got 1.1% to go to 1.3%, we're doing our happy dance. Yay, did we do fantastic? And then the folks from the new data science department said, well, let me take a look at your list and see if I can build a predictive model. And I'm like, okay. And it went from 1.1% to 6%, which was, I was like, oh, and they spent about an hour. And I'm like, 1.3%, 6%, 1.3%. You know, that 6% looks a lot better. So I made a deal with them. I was willing to be their guinea pig to be able to test on different marketing programs. But in exchange, what they had to do was to teach me how to do data science. And that's actually how I got into the field.
Very, very interesting thing. So you started with something called as A/B testing, right? That we train people upon. And that experimentation led to a trigger in your brain, probably, that, hey, this could make a lot more difference if I knew data science pretty well. So,
absolutely. My undergraduate background is not in, I joke with people. My undergraduate background was strategic planning. My MBA is in strategic planning. Okay. So for the first half of my career, people said, you can't possibly do this job because you don't have a PhD in statistics.
Yeah.
And in the second half of my career, people say, you can't possibly do this job because you don't have a PhD in computer science. Okay. And I'm like, okay, well, I've been doing it for 34 years. So, maybe it's possible without a PhD in either. But it's been this huge shift in terms of what people know. But you have to be able to take problems and solve them. So actually, strategic planning, as odd as it sounds, turned out to be a great introduction for me, because I was always focused on, all right, what's the plan? What are the objectives? How are we going to measure it? How are we going to implement it? How are we going to communicate it? All those types of things that come from more of a strategy standpoint have really turned out to be amazingly helpful.
Amazing. I mean, I can relate it with what we do here. So we get a lot of these non-computer science, non-statistics learners as well as part of our various programs, or when we engage with corporates. So we realize that one of the main questions that they ask is that I'm not from computer science background. I've not done a master's in statistics. So am I fit for learning data science? Our response always remains that, do you like to ask questions? Right? I mean, when you go to a pharmacy store, or when you go to a multiplex movie theater, you like to ask your question. Do you like to ask questions as to how many people are actually watching the movie today? And if there are only 30% of the seats occupied, how are they making money? So, I mean, we always say that, do you like to think like a kid or question like a kid? If you do, then you can actually learn data science. And we've been successful in doing so. I can very well relate with it.
Curiosity as a force multiplier.
Absolutely. Curiosity is very, very important, especially in the world of data science as well.
Yep.
Yeah. Wanted to ask you one more question here.
Sure.
So, because a lot of people who watch our YouTube channel are very young, so they're just getting into data science industry. What kind of tips would you give, 3, 5, whatever your favorite number is, to young data science aspirants who are just about to get into this industry?
Sure. 1, the industry is about problem solving. That would be 1. 2, we just finished talking about curiosity and the need to continually learn. If you're not willing to change everything that you know every 5 years or so, this is probably the wrong industry for you. Back when I started, the field was KDD. Knowledge discovery and databases was what it was called, which is where KDD nuggets came from. Then it was data mining, which used to be an insult. You used to call somebody who was digging for something in a database that didn't make a whole lot of sense. They were trying to find a certain number of records that would fit it. So people would say they were mining the database. But then it became the name of the field. So it was weird. Then it was predictive analytics, and then we've gone into data science as a term, et cetera, and so forth. The techniques, back in the dark ages, everyone used SAS as the software. And if you didn't have, sort of a black belt in SAS, you weren't able to do anything. Now, SAS has gone to supporting lots of open source. It's very different now than what it used to be. Neural networks actually go back a long way. All right, that's continued to be the same, but it used to be you had all sorts of other techniques that people don't use anymore in terms of algorithms for solving your problems. Things are going to continually change. You need to be prepared for that. 3, recognize that the process for hiring and what you actually do in the job tend to be very different. The process for hiring tends to be a lot of coding tests, as we talked about, questions about algorithms just now. What you're going to spend most of your time is cleaning up data. Anywhere you go. I haven't been in any place where that isn't true. And I'm very fond of the joke that 80% of the data scientist's time is consumed by data preparation and data cleaning. The other 20% of the time is complaining about doing data preparation and doing data cleaning. But that's where most of your time is going to be spent, no matter where you go. Even if it's relatively clean data, you're going to have to do your feature engineering, which is where most of the power is, not from the algorithm. So those would be the top three things.
Okay, very good. Very, very nice. So being able to ask questions, be curious, keep learning. 5 years down the line, the things that you probably have learned would have changed. We have seen how SaaS started. SaaS was SaaS. I mean, I remember 2003.
SaaS was a religion. I mean,
Yeah.
They almost had temples to SaaS. I have never seen obsession with a software solution like I've seen for SaaS, even now.
Yeah. So I remember in 2003, in my master's in information systems, we had SaaS as an industry partner in Texas, and that was the main learning program. That was the main business sciences program that we learned for all 1 year of my second year of my master's. So I remember, I mean, SaaS used to be a religion for all the way till 2010, 2012, and then automatically things started to change. So yeah, we have seen that. So that's a very, very important point. Second, which is keep learning. And the third point you said is that even though the hiring test would be on coding, on a lot of these algorithm based, but you will end up doing a lot of feature engineering, data cleaning. So be very, very good at that as well. And we also saying the same thing to our folks that 75% of the project times goes into data preparation and data cleaning. And at some point of time, the interviewer will actually focus on those kind of questions as well. So be ready for that. So it's a very good suggestion. Wanted to ask you one more question since we are going through a pandemic time. So what changes have you noticed in the world of data science? Has it benefited out of the pandemic, or what really has happened?
The industry has gotten weird since the pandemic. There was a trend that was already happening prior to the pandemic that seems to be true, especially for folks in the audience who are looking for the first data science role. 2012 was the year where we had the big thing in Harvard Business Review about data science being the sexiest job of the 21st century. By the way, I keep trying to convince my wife of that. Hey, I'm in it. I was like, okay, I tried. Anyhow, and it used to be people were desperate to get anyone into data science, and everyone told everyone else, you need to get in data science, and they're desperate for people, and oh man, you can get a job instantly as soon as you. That's not true anymore. Okay. The competition, even for entry level roles, has gotten pretty ferocious. Okay. There are definitely gaps where there are huge holes in where people want to hire folks for a position and they can't find them. But it used to be you could have anything to get an entry level role. That's not true anymore. You really have to have real world experience in some way, shape, or form. So be aware of that, focus on that. Make sure that you have a GitHub repository. Make sure that your resume is set up as following. I improved X by Y. So I started at this level. You need to have numbers. Everything needs to be a quantifiable result on your resume. Responsible for, take that out of your resume. No one cares. And for God's sake, do not put the classic data sets in your resume. I don't care what your performance was on Iris or Titanic. Don't put it in there, because as soon as the recruiter sees that, they're like, everybody knows how to do that. Why? That's important enough to list in your resume. It's actually now takes away from credibility as opposed to improving it. So those would be a couple things.
No, I think the last point that you mentioned about X improved Y, or I did Y and that gave me X results. So basically, you're trying to say that focus on the results more than just being responsible for doing something.
Yeah, take the responsible for out of there. Every bullet point should have a number attached to it, and the number should be towards the front of your accomplishment. Okay. People want measurable, especially with data science folks. It's true and generally for human resources folks, but if you're trying to get into a data science position and you don't have a measurable result, what you're basically saying is one of the most important things in my life is getting this job. Okay. And I can't come up with a way to measure that. That's not really the way you want to present yourself for a data science interview.
Absolutely. You're right. Very nice. Very good. Very good. Very good. I'm going to ask you a fun question. Okay. I chose my wife, or probably, sorry, wrong term. Maybe my wife will listen to this. I proposed to my girlfriend by doing by creating a small data model. Okay. Have you done anything fun with the knowledge of data science that you have?
Have I done anything fun with the data science knowledge?
Not that proposing to girlfriend was fun, but at least it was non-work.
Everything I've done, I think, has had a work component to it.
Okay.
What I find fun actually has been mentoring folks younger than me.
Okay.
And trying to help them move their careers along. So for me, that's fun, and it wasn't part of really what my job was set out. I am also working on something to put on YouTube for fun.
Okay.
Which is, are you familiar by any chance? Probably not. Gilbert and Sullivan, Pirates of Penzance?
No.
Don't worry about it. There's a song in there where people are making fun of the military. And so the Major General comes in, he does a whole song about how important it is, how wonderful it is to be a modern Major General.
Okay.
And I am converting that into being a data science general. So I'm getting ready to sing my patter song on being a data science general, but I'm not quite ready, so I can't do it today.
Well, all right, good. Thanks a lot. Just one last question for you, Scott.
Sure.
A lot of people are confused between these terms, AI, data science, machine learning. Can you describe them in as short as a message?
I can try. I can tell you that to a large extent, I am raising the white flag of surrender in terms of the terms have become so muddled now that it doesn't matter. It almost doesn't matter what the real definitions are, but data science to me is the broadest of the categories.
Okay.
And so it involves data preparation, databases, sort of theories of what a data type should be, that type thing. I think it also includes what a chief data officer would sort of include in terms of data purity and one source of truth and all those types of things. Okay. Machine learning is a subset of data science, which says, I've got some set of data. What's an important pattern that other people haven't seen before that I can share with folks? And that pattern is your model.
Okay.
So I'm trying to either understand something with an unsupervised model, or I'm trying to predict something with a supervised model. So that's sort of the two pieces. Artificial intelligence, I think, is a lost cause. The original definition that I learned for artificial intelligence is the ability of a computer to do something that it has not been explicitly programmed to do.
Okay.
I don't know of anything that we're doing that's remotely close to learning where it wasn't programmed, because even if it learned something, it was programmed, the learning process.
Right.
So AI has basically become, in my opinion, meaningless. The closest I can come up to it is autonomous vehicles. Okay. But still, it was trained, folks. I mean, how they train, reinforcement learning is still training. So I think that's but now everyone wants to use it as a phrase. My brand new product includes artificial intelligence, and therefore you should pay me a lot of money for it. And now you run into people, oh, you're an AI? Absolutely, I use Microsoft Excel. Oh, okay, that's not really how I would define AI, but all right, good for you.
No, good. Thanks a lot. So very important key takeaway from your discussion today, Scott. Really fun to have had that conversation with you. You said 3 important tips for any young data science aspirants. Keep asking questions, keep learning, second. And third, be prepared to do a lot of data cleaning, feature engineering, data preparation kind of work. So be very, very good at those things. And also you gave one very important message that a person doesn't have to be a computer scientist or a statistician guru to get into the field of data science, as long as you have a habit of asking questions. Great chatting with you, Scott.
And I have one final inspirational story, if you're so willing.
Absolutely, please, more than willing.
It's a personal story. It isn't a very happy story, but it should be illustrative, and I hope it can be inspirational. Yeah. Once upon a time, I was vice president of consumer lending for Bank of Hawaii in Hawaii.
Okay.
And my career was really doing well. I was really happy, all those types of things. And my wife at the time decided to kidnap my son and take him back to Baltimore without me.
Okay.
So I had to give up my career. and go back so I could be with my son. And there were no more financial services places in Baltimore at the time. And I was like, what on earth am I going to do? I had to work as a temporary secretary for a period of time until I could find something else because I needed to be near my son. And then one day I thought to myself, I wonder if anyone's interested in that machine learning, artificial intelligence stuff. I was like, wonder if I could do some consulting in that. Would that work? And that's what actually launched the full-time part of my career. So I went from the absolute bottom of the barrel in terms of what I was planning on doing to have to make that turnaround. And I did that without a computer science background, without a statistics background. Now, if I can do that and sit on a podcast today to help others, if you put in the work, you can probably do it as well. So try not to lose hope, because at that point, I really felt like sticking my head in the microwave and pushing flambe. But I didn't do that, and that turned out to be a good solution. And everything's fine now. My son's happy and 25 years old and has a career of his own, and it's, all ends happily.
Yeah.
But let me tell you, if I can pull myself out of that hole, you can probably do something similar.
Very inspiring, Scott. Very, very inspiring. So, Scott, you've been an author, you've been a guest lecturer, you've been a data scientist, you've been a solution provider, problem solver, and that's how you, and you're a storyteller, and that's how you like to explain who a data scientist should be. Thanks a lot, Scott, for
You're
all
so
the
welcome. I really enjoyed it.
stories. Thanks. We had a great time with you. Thank you, Scott.